And it's week 2 in Business 2220, Statistics for Business and Economics, and already we're 2 weeks into the semester. Today I'd like to do a problem from Chapter 2. We're going to do a histogram. This is probably one of the most difficult charts to create. It requires a little bit of work, but after you get the hang of it, it's not all that bad. And like most things in statistics, it's not a cut and dried solution either. There's some room for originality and artistic expression, even in constructing a histogram. And I'll show you where some of those areas lie. Now, it's asking us to just walk through the steps, basically. If I have a problem here. There's 2 steps are put together. But first we find the number of classes. Then when the class, let's go through it and see how it works in real life. Let's get the data first of all. It's histo data, and you recall that we can get those from the student CD, but if you don't have one of those, we can go to the website. Let's go to the website. Where did I put the website? Here we are. I'll start from scratch so you can see what I'm doing. McGraw-Hill-Higher-Education.com, MHHE.com/Bowerman, ESS for Essentials, 4th edition, 4E. That takes you to the student page, to this page rather, where we select the student edition. We select data sets, and we look for histo data. There it is right there. We click on that. We open it with Explorer, in my case. You can do it a number of different ways, of course. And once I get that, I double-click on it, and there's the data. Now, I'm just simply going to select that data, and I'm going to copy it with the famous copy command here. And then I'm going to get rid of this data sheet and go right over to my other one where I have the problem over here, and I'll paste that data right in. And it's called value now. That's all right. We don't care. And I'm a neat Nick, so I'm going to center it all, make it look nice and neat. There we are. Get rid of value and call it histo data. Okay, first thing is find the number of classes needed to construct the histogram. Well, now, to find the number of classes, we need to know how many data elements there are. Now, you can go down and count these one by one if you want, but I'm going to use the count function. And now, to create a function in Excel, or an equation really of any sort, you start with an equal sign. That tells Excel, this isn't just plain old text. I want you to do some calculating for me. Now, after the equal sign, I put in the function name, which in this case is count, as you might expect, an open parentheses, and what's going to be within the parentheses? Well, the values that I'm interested in. And I can simply click and hold down my mouse button on the first data element, drag down to the last data element, thusly put my ending parentheses in, and it tells me that there are 28 data elements. Well, that's, really kind of silly. We could have easily figured that out, but I just wanted to illustrate how Excel can be used to do some of these things. Now, the next thing is to find the class length. Well, there are a lot of ways of doing that. There's a fancy formula in the book you can use if you wish, but it's just as easy to flip to the textbook. Where did I put it? Here it is. And go to section 2.2. Hello, section 2.2. Where are you? Let me move this over so you can see what I'm doing. And why am I not going to section 2.2, one would ask. And go to section 2.3. We'll go to back. There's section 2.2. And it tells us on the next page, I believe. Yeah, here's the table. Table 2.5, found on page 43. It says, depending on the size of the data set, now remember we had 28, so we're somewhere in the 16 to 32 range. It recommends that we use 5. Now there's, as I say, a formula that generates this table, but just look at the table and pick out the number that you need. Once you have that, we can go back to our problem and we just plug in that number, 5. Now, define the overlapping classes for the distribution. Well, we know already that we're going to have 5 classes. 1, 2, 3, 4, 5. Now, how do we determine what the length of each of those classes is going to be? We know that the first one's got to start with the smallest data set. But what is that? Well, you could scan down that list if you want, but I'm going to use Excel, again an equal sign, and I want to know, Excel, what is the minimum value in my data set? So I'll just type in the word min for min, close the parentheses, and I find out the minimum is 17. I'll put that over here so we remember what we're doing. And then what's the max? Well, of course, there's a function for that too. Equals max. And we get the answer of 46. Now, again, you could have looked through the table and found that answer easily enough. But now there's another interesting question. That is, what is the range? What's the difference between the minimum and the maximum? It's 46 minus 17. C17 minus C16 in Excel's words. And that range is 29. Okay, interesting. Now, we're told that we want to divide this range into 5 pieces. How are we going to do that? We know we've got 28 data elements. We want basically 5 non-overlapping intervals or classes that we can divide the data into. Now, to find that class length, we have to take the range, 29, and divide that by 5, the number of classes. Each class should be 5.8 data elements long. Well, 5.8 is kind of an awkward number, don't you think? Let's round that up and call it 6. Just because that's a nice even number and it doesn't have that fractional part. Now, as I said a moment ago, the first class has got to start with the smallest data element, which is 17. And the end of that is going to be 6 units higher, or 17 plus 6 is, anyone? 23, right? So the next class starts where the last one left off, is 23, and 23 plus 6 is 29. We go from 29 up to 35, and 35, I'm just typing these in obviously, up to 41, and 41 to 47. Okay, now there are 5 classes. They're equal length. Now the problem we have next is to do step D, which is to tally the number of values in each class and develop a frequency distribution. Okay, let's tally how many data elements fall within the range of 17 to 23. Well, let me show you one thing that we can do to make this problem a little bit easier to do. We could select all these data elements. Notice I did not select, I will select histodata, the column heading. And let's go to the Data tab. And again, you can do this in Excel. I think it's in Excel 2003. I believe it's on the Tools menu, but don't quote me on that because I'm going by memory, and my old memory isn't that good anymore. But hey, let's try it and see what happens. We're going to sort this data. Now, it says, warning, there's data of a similar sort nearby. You can almost always say, continue with the current selection. Now, it's asking us, first of all, you got to be careful with the sort thing. Notice it says my data has headers. I have to check that because remember, I selected that header, histodata. What happens if I don't? Well, it's going to sort histodata along with all the other numbers rather than leaving it as just a heading, which we want it to do. And it's going to sort histodata by values. from smallest to largest, and that's what we want it to do. So let's sort it. Okay, now we can look at this and say between 17 and 23, we have four data elements, right? Let's make those red. There we go. And we can put in the number 4. Okay, how many are between 23 and 29? We'll make those blue. Well, you can see there are 2. How many are between 29 and 35? 35. Well, now, here's the problem. Do we include 35 in this class, or do we put 35 in the next class? Well, the book would tell us leave it out and save that for the next class, for class 4. I'll talk about this a little bit more in a moment. It's not quite as cut and dried as it might appear. The thing that you've got to be, however you do it, you've got to make sure that you don't count the data elements twice. It would be wrong for me to include the 35 number, the 35 data element in class 3 and class 4, because that would be double counting. Okay, moving on, 35 up to, but not including 40. We'll make that one orange. These are getting kind of similar, aren't they? Hard to tell the colors apart. Let's make it green. Okay, they're I don't want to count those. Let's count them this way. Equals count. And I just select all the green ones. 14, okay. And then 41. Now remember, because I rounded up, 47 is actually a little bit beyond the limit of my data, because it came out to 5.8 and I rounded up to 5 to 6. So, but nonetheless, we have 4 data elements there. And there we have it. There's our histogram, our frequency distribution. And let's draw a histogram now of this. So let's select this data like so. Let's go to the Insert tab and do a column chart. We'll take this one, the first one. It's calculating, it's calculating. Oh, there it is. We have it, ladies and gentlemen. Okay, there it is. That is our histogram. Now it's kind of, oops, what did I do? Clicked on something twice. I want to get rid of this. I hate these little things when it tells me Series 1 over here. Now, the only problem with this is it doesn't give a title on the chart, so we could jazz it up a little bit by including a title if we wanted to. Let me just check something here. How am I doing on time? I'm up to 800 seconds. So, okay, let's keep going just a few more minutes. We could put in a title in this chart, couldn't we? Let's put a, let's see, is it in layout? Data, chart title. Above the chart, please. Okay, thank you. And we'll call this histo data. Whatever the histo is, who knows, who cares. Okay, there we are. There's our histogram. Now it asks us to create a relative, one thing I should have done is just double check my work and make sure I didn't double count, that I really come up with 29 data elements. 28. Ooh, what did I do wrong? Oh, that's the range. No, there were 28. Yes, that's right. That's right. Whew. There for a minute I thought I'd blown it. 28. That's right. Okay, so I've got them all. Now, what is the relative frequency distribution? Well, we simply take each value and divide it by the total. And that says that 0.14 or 14.2857%, let's do it as a percentage, equals that same number expressed as a percentage. I give it a decimal point or two, it doesn't hurt, is 14% of the data elements fall in category 1, from 17 up to but not including 23. Well, I can do that same formula over again, equals that divided by, this is a lot of work. Let me show you a trick. If I take this formula here, F10 minus divided by F15, I'm going to put a dollar sign in front of the 15, and I'll show you why in just a minute. I think I've in today's in this assignment 2, I believe I've given you some instructions on how to do this. Dollar sign tells Excel to do something special. Now, when you notice in this cell also that there's a little black dot down here in the bottom, I'm going to drag down on that dot, and what happens? Well, each time I move down a cell, what was F10 divided by F15 becomes F11 divided by 15, F12 divided by 15, 13 by 15, and 14 divided by 15. What's happened? Well, the dollar sign tells Excel, don't change the reference for the column, for the row rather. I always want it to be 15 no matter what. But you can change the reference for the other number and let it increase as I move down from cell to cell. I can do the same thing. Well, it's the same number, so I just pull that down. And there are my percentages. Now I can go ahead and create more histograms. Insert, same thing. There it is in terms of the relative histogram. Or I can do the same thing and show the percent histogram. And you can do this all day and have lots of fun. Okay, that's how you create a histogram. I'm going to do a part B video because I want to show you how Excel would go about creating a histogram, mostly to make a point. So tune in and take a look at the week 2 part B video and see what Excel would do. I'll be right back.